Okay, so let us get started. Let me minimize this. Okay, so let us just revise what we studied last couple of sessions. So we looked at logging. So as you know that logging is one of the helpful techniques to capture the events of the process. So if you put the logs in right places, so you won't be um, in dark in the sense that when your process is running, it won't dump your print statements to your monitor because monitor is disconnected and process keeps running in the background. And when these processes are running out in the world and something goes wrong, and if you want to analyze what's happening, so logging is one of the best solutions. And almost every language has its own logging. And in Python, we saw that there is a library called as logging, and there are different types of logging. We can set the logs to dump the logs to a particular log file, and then you can also set the diff levels. So I was explaining, so there are like 1, 2, 3, 4, 5 5 levels. So if you set at the basic one, debug, where it enables all of these flags, all of these logs gets printed. We also looked at this, how it looks, and you can change the formats of um, the logging. We can, this is the timestamp, and most of the IDEs or most of the log analyzers will highlight the timestamp and other things here so that it's easily readable. So that's about logging. We also looked at unit test cases. So how, what is unit tests, and how do they help in testing testing your own functions. So once you get used to that, it ensures that anything that you anything that you do from your code, it's not broken. For example, you develop a feature, say news.py today, and then you write unit tests, and then you change some of the things at news.py, say next week, and you don't have to like re uh, take a relook at your code, like the old code. You can just run the unit test cases, and it ensures that okay, things which were already developed are working fine. So that is the advantage of unit tests. And there are several different levels of testing. So I was explaining that, okay, at developer end, you have unit tests, and then you have module tests. And then once it goes out of the development team, there are different teams which have their own test cases: integration testing, end-to-end testing, stress testing, like performance testing, security testing, and so on. So until it goes out to the world, there are like different levels of testing. They use their own frameworks, and they do the testing. But at developer end, we should be ready, or we should be in a position where, according to the requirements, we should not have any bugs. Unless it's quite complicated situation where there are multiple things involved, dependencies involved. Um, at your end, we must make sure that these things are working fine. So that is how our unit tests help us. So that's about unit tests. And yeah, so far what we have covered is how various different interfaces, how to debug using PDB, logging, and exception handling, and so on. So this is like basic Python you already know, and you already know, like if you just take any code and look at that, I'm sure you'll be able to look at what's happening in the code. So this is the current level, and today we will discuss, going further, we will discuss about databases. So it's good to understand how the databases work and how to operate on top of this. And then so far we were acting as clients, in the sense that, for example, to access news, we use this script. To access, say, to send mail, we use this, but the server is something else. Server in this case is smtp@gmail.com. So similarly, for calendar, we were acting as clients. We used Google server as the destination server. So we will also learn how to create our own servers and endpoints, just like the endpoints that we are using in calendar library, and how to create a server and how to give access to subscribers. So we will do that in this week. And then we will combine all these things into a nice package, and we should be able to interactively you enter the name, age, and subscribers details that should go into the database. And from the database, we should be able to send them mails, which is the subscription details, saying that okay, this is your today's news, and this is your these are your tasks from calendar, and this is the weather in your city or something like that. So that is what we are going to achieve in this week. We'll also learn some more other things, auxiliary stuff, which are related to Python and software development. Okay, that's the target for. Today we'll learn about databases. Okay, so I'll just tell brief about what are databases, why they are used, and how they are used. How did it come? Like why people started using databases and types of databases and so on. Okay, so let us just the basic theory part. I'm sure you have used the databases most of the times, but if you're not coded, it's invisible to you as this database. So why do we need a database, and what are the problems if we do not use the database? We'll just see. Okay, so database is nothing but it stores data, right? For example, your normal file, say a.txt also stores the data. So if I want to say store username and say email ID, user and email, I can simply store in .txt, right? There is nothing stopping us. So why do we need databases specifically? So let us try to understand the problems here. So if you are using the text, it so happens that your text is growing, and anybody who has access to a.text can access all of these values, like user dot this one, and imagine that there are multiple tables, say a.text or b.text or so on. So each of these tables are text. If you store everything in one text, they have got access to everything. So that is one of the problems. And the another important thing is that separation of the process and the data. So far we have seen our processes like say subscription service dot py, say for example, this is our service which is running in our server. If you keep the database in the same system here, so this is your database, and if you keep entire thing in one system, so it may happen that one of these things go down, or if the server goes down, both of this, which is your process and the database, both of them go down. It won't be accessible. So what we generally do is keep the data separate in a different server, DB. So this is your computer, and your process in another thing. So this is your say software which is running. Okay. So now this is independent. Okay. So if this goes down, so all the data that we have collected so far, imagine say we have collected data for like 1 year, and we are running say a school's database or a college database, and all the students' names and details, everything is here. And if the server goes down, you won't be able to. get a new server, or hop onto the new server, and then migrate everything to something else, and it's difficult to do that. So, and you are putting your data and your software, both of them, at risk. So what we generally do is um, so run the software here, and also we have multiple copies of databases. So this ensures copies. So there are different functions or different features in any given database that you can take backup of databases every day and so on. So the database operations and your software operations are kept separate. So that is why we have different roles. For example, DB admin roles or DB administrator roles here, and software engineers just like people who are developing software, right? So they take care of administrating all these things. So in case if this database goes down, the server goes down, you always have a copy, and you can also instantiate a new server very quickly. Okay. So that is one of the reasons. So we discussed one problem. Second problem, and um, how does this? What are the operations in database generally? Okay. So database is nothing but, if you have used Excel sheets, it's exactly same thing, but it has additional features. For example, Excel sheet has sheets, right? So let us try to like visualize commonalities. Excel sheet or spreadsheet or whatever you're using, Google Sheets. So it has got a sheet, and that's got like the entire what is that called? Sheet one, sheet two. You can have multiple sheets within this, and entire thing can be in one Excel sheet or a spreadsheet. Spreadsheet. And then each of these sheets have rows and columns, right? Like A, B, C, D, and then 1, 2, 3, 4, like that. So rows and columns. Okay. So databases also have the same thing. So the difference between the Excel sheet and the databases is that Excel sheet is right on your laptop. You can just double click and open, and whoever has the access to Excel sheets, he can or she can look at all the data, and it doesn't have enough security and so on. So there could be cases where, for example, I am a subscriber. When I click on get the weather data or get whatever the personalized data that I want, when this guy is subscribed to his own city, for example, Bangalore, so there. So we should not send entire list of weathers with other cities data, right? So we should be in a position to segregate the data according to the subscribers or according to users. So these users are like these are called views. So one person has a different view. For example, administrator can see everything. So you could be say class teacher. Right? Say class teacher is one of them. So views are roles, okay, based on the roles. So class teacher, say class teacher of say second standard should not have access to 10th standard, right? So he or she should be able to operate on only whatever is given. So this sort of features are present in databases. So this is called access, right? So database access. So these are the terms which you have used already, but in the database context, it is similar thing. So you have access to them. So we also learned about authentication and authorization, right? So this is what authorization means. For class teacher is authorized, second class class teacher is authorized to see only the second standard data, but she is not authorized to view 10th standard data. Right. So that is, but she can log into database, or she has access to the database. Okay. So, and what are the operations on top of it? So these are like basic features which you now you have connected Excel sheet and like database, how it works. So they are just tables. So multiple tables are put together in one database, and you can create multiple databases. So let us understand what are the operations in databases. Operations. So in any file operation, because this database is stored as some file, but it is not like a text file where you can open it and start seeing it, right? So database itself. Uh, so there are several softwares which offer the database services. For example, you might have heard about MySQL, PostgreSQL, and SQLite 3. SQLite. SQLite is a lightweight SQL, and it does not have a lot of features which are offered by this. And there are two types of databases. So all these are under what we call as RDBMS, Relational Database Management Systems, RDBMS. Relational Database Management Systems. So what does relational means? We'll see in a minute. So operations in a database is just like REST APIs, right? REST APIs we saw that there is like GET operations, there is POST operations, there is delete operations, and so on. Similarly, in database, we have just like your files, like you can add text, you can delete text, you can modify text, and so on. Databases have these operations. One is to create an entry, which is insert, and you can also delete an entry, delete. You can also update an entry, which is like modification of existing data, update. So insert, delete, update, and yeah, they should. So these are called as CRUD operations. You might have read in blogs. So CRUD is nothing but create, update, delete. So these are the main three operations any database have. So this is like, so when you hear about CRUD anywhere, it is nothing but these operations. So example of insert is just like you're creating a new data in Excel sheet. For example, let us say I have a table called subscribers. Subscribers is a table name, and table has attributes, right? So what are those attributes? Probably it is name, say age, and then say email ID. You can have more here, like location and so on. Location. So this is what is a table, right? So when you say you want to insert one of them, so insert operation comes into picture. You can insert a name. Say, let's see, ABC, and say 20, some ABC at the rate something, and so on. Similarly, you can add like XYZ and so on. Okay? So these are your database entries. So this is fresh entry is called as insert. Delete is anyways to delete one of the entries. Update is where, for example, person ABC has updated his email ID, and we want to like remove this entry and, and add an entry. So that is called as update, because we are not updating or we are not removing the entire row here. We are not operating on entire row, but a part of that. So that is called as an update. So it is like opening Excel sheet and just operating on one cell. Okay. So that is about just to get the mental picture of what are the operations and so on. Okay. So these things you already do it, but just to bring your Excel sheet or spreadsheet context into databases. Now there are multiple. There are mainly two types of databases in software that we use. One is called as SQL databases, which is I'll tell what is SQL, and then there is something called as NoSQL databases. So what does SQL databases means is that I was talking about RDBMS, right? Relational database management systems. So what does a relation in a database mean is generally you'll have multiple tables. You can have everything in one table, but the problem is it is not scalable to update something. There will be multiple copies and so on. So usually what you have is you can read about those things. You can search for keyword called as normalization. So I don't want to get into this because it's a big topic in itself, but you can read about why do you need normalization, database normalization, and so on. So there are simple examples and so on. But finally, we'll have multiple tables. For example, this table could be subscriber table. Okay. So name and email ID. So just for simplicity. And then you could also have a table, say, your location and yeah, location is one table. Okay, so there are like several locations, and in order to say I do not want these locations can get added, removed, and so on. So location has its own table. So let us say this is latitude, longitude, and say some city or something like that. So when user chooses what location subscription he wants, so either you can add the complete details here, like latitude, longitude, city, and so on, the complete address, or you can simply add an entry which is a reference to this, so that for example, let us just assume that this row is too big, like say 10 attributes. Instead of adding 10 attributes here, you can simply add a number. Say this in Excel sheet, imagine that there is a sheet called as location, and then that particular row number, you can simply add that row number here. So which means you are saving, you are not copying the entire data, but you're just referring to that particular row. So this is what a relationship means. So, and in database terms, it is called as foreign key. So the numbers that you have in Excel sheet, right? Like for example, you can add 1, 2, 3, 4, 5, 6 like this. So these are called as primary keys. Okay. So they can be numbers, but you can also configure it to something else. So idea is every table, every entry has its own key, which is called as primary key. And if it is referring to some other primary key from some other table, it is called as foreign key. So that's all. So it's a quite simple concept. So it's like you are referring table in one other table in your Excel sheet using that the row number in another sheet. So that's how you can imagine. So yeah, by doing that, you'll save a lot of space, and you can modify this table independently of this. For example, say city name gets changed for certain latitude and longitude. If you had like copied the entire data, you'll have to make, say, probably all the places where latitude and longitude is pointed to city. So city name is changed. Okay. So for example, Bangalore became Bengaluru, right? So you'll have to change at all the places here. Like it probably like thousands of people have subscribed. So instead, if you just had an entry, a foreign key entry, so you can just change at one place. And that change will automatically reflect here because we are not storing at all. So that is the advantage of having a foreign key. So the tables can be independently operated and managed. Okay. So that is about tables, primary key, what is a foreign key, and what are the operations. So let us get back to this particular thing. So that is what is your RDBMS. RDBMS means, so it has got tables and relationships like this. Okay, we will look at some examples. So these, in order to operate on these tables, so there is a specific language called as SQL. Okay. So it is a query language, and I think let me show you some example. Yeah, how it looks. This one. You can see that there is like specific. There is this. Okay. So these are like, this is how it looks. So S in SQL stands for structured query language. Okay. So like, okay. So this is how it looks if it has got select and things like that. So let me just show you one complicated syntax. Let's go created query with say, let us look at this. So I'll just explain what this does. So in SQL, um, I was talking about like you can reference different tables, right? So in this particular code, so um, there is okay, there is, I see there are three tables. How you can see is that there is products, there is categories, and there is suppliers. Okay, so these three tables are like totally different tables, right? Because one person who is handling or managing say categories in the product category, so he can independently manage that, add and remove the new category and so on. That will automatically reflect in different tables with using foreign keys. So here what we are trying to do is you're trying to get one of the attributes product name from product table dot product name, category name from category table, and then supplier name from supplier table, and then you're doing some join, inner join, and this another join. Okay, what it means is you are trying to you must have been like familiar with Venn diagrams, right? Say this is a product, um, all the products, and then there are like categories, probably product categories, and then there are like suppliers. Okay, product suppliers. So based on your query you can suppliers and so on. So you can you can actually choose that for this particular product, for given supplier, so you can, and given category you can just select this particular thing. Okay, so you can, this is like a filtering, right? For a given product, go to those suppliers which are um, who are supplying that particular product, and then what are the categories of that product. So you are going to get those, and then this is the result. So this is filtering. So this filtering technique is done using joins. So you don't have to like learn like everything at like today, because this takes its own time to understand and operate. But this is how This is one of the features in relational databases where you can use joins to filter out certain things. Okay, so this is a query. So this is a select query. From is a keyword, and then it does this. Okay, so you do not have to remember this at this moment, because you can generate these queries on your GitHub Copilot, but just understand what to ask when you are operating on databases. But yeah, let us get back to our code. So that is about databases. So NoSQL database, okay, that is the SQL databases. And what is NoSQL database is they are mostly like a dictionary. You can imagine that we have learned about dictionaries, right? So dictionaries has two things. One is key and value, and that is stored generally in your RAM. So you can also dump it to your hard disk, which is called as persistent databases. So all the SQL databases are persistent, where all the operations that you do, it goes onto the disk. Okay, so most of the NoSQL database, where you're not using SQL queries, but you're using different mechanisms. So there are several databases which we are not going to look at, but you just need to be aware of it. So you must have heard about MongoDB, Redis, and I think there are several others. But yeah, they operate on key and value uh, idea, where you can just store the key, for example, email ID, and then you get the student name or something like that, and then you can operate use that in your process. So yeah, we are not going to look at this, but just be aware that there are no SQL databases as well. Now we are learning about SQL databases because they are persistent, and they are generally, these NoSQL databases are used in conjunction with, or along with, the persistent databases. So the advantages of using the NoSQL database is they're pretty quick in accessing. Like you can access quite fast. So this has got its own, you know, since you're retrieving from hard disk, and it has its own way to cache things and bring the data. It is slightly slower, but it's not like too slow. Slower than this. Okay. So because this is residing in your RAM. So when you instantiate the database, so all the data is available in RAM. So that is the reason it can fetch things faster. So yeah, that is about like NoSQL database and SQL databases. So they're independent, but generally in software design we use it together. Okay. For example, if I want to fetch, um, say Elon Musk is tweeting. So Elon Musk has like millions of subscribers. So that tweet, if it is stored in SQL, so 1 million people are like 20 million people who is trying to read that data. So even if it is like 0.000 and 2 seconds, so this will add on to like a lot of time to get that tweet for every user, right? But if it is stored here in NoSQL database, so this reading becomes very easy for everybody. So that is the use case of using NoSQL database. But it doesn't mean that we are not storing Elon Musk's tweet in SQL database or persistent database, because that needs to be stored for like future users, right? So whenever there is high traffic, so whichever is getting accessed very frequently, we keep it in the NoSQL databases, or yeah, you can call this as cache, caches. Sorry, cache. Okay. So yeah, they are independent but generally used together. Okay? So that's one of the use case that you need to. It helps you to understand what is the use case. Okay, now let us get to code. Okay. So now that we have understood what we are trying to do, so any database, since it is running on different server, you can of course run it on your own server. So it has three things that it needs. Okay, one is the IP address or the server's name, um, the complete DNS name. And you also need access to that, right? So you will need username and password. So this is in general, these are the things, three things which you need. So it is just like logging into another computer, right? So let us take this. Let me create a file here. DB operations. Okay. This is a fresh file, and Python has got inbuilt database called as SQLite. So we will just generate the code for that SQLite and then understand what we have learned. Okay. Snippets for thread operations using SQLite. Version is 3, so I can snippets for and just ask so that we can go easily. This is SQLite. Okay. Now you know what is CRUD operations, right? Create, update, and delete. Create, read also. Yeah. Create, read, update, delete. Okay. So let me just bring this here into this and try to understand what they are. So whenever you read the code, you need to go at like first function which gets called, which is like under this, and see, okay, this is database, and this is something else, connection, create table, insert, and fetch users. So the function names should be in a way that the reader should be able to easily understand it. Okay, so let us try to run this program and then let us understand what it is. Okay, so I'm going to run this. So it has printed users, something like this. Okay, so let's get back, which means this program is working, and let us try to understand from here. So any database, as I was explaining, it is generally hosted somewhere else. So in our case, it is hosted in our own local host. So this particular SQLite, it is a lightweight database, which means that it does not have you don't, of course you can uh, use some authentication and all these things, but in by default it does not have, you don't need to have username and password. So this helps you to understand how databases work, and then you can later on jump to different databases where and keep that database in a different server and try to access. So in general, you create a database or you sort of connect to a database. Okay, so database is actually a file which is on the hard disk, but the service like SQLite, PostgreSQL, MySQL, PSQL, and MySQL, so on, they utilize this database and they run a process. Okay. So they run their own process, which is called as service. So each service, when you instantiate this, install or bring up the database, it will have, you can see that port is there is an open port, and then there is a database file attached to it, and you can access via that particular port, host, port, and yeah, there are ways to access using service name as well, but host or port, and then you can have username and password for authentication. Okay. So this is what is a database service main. So in this case, in SQLite case, it is simplified, saying that this is just a file and you can access those files just like any other database. So connect to DB is, I think it's a function that is written. So any database can be connected using those parameters. So you send the database, and there is a function here which connects to database, and then you're creating a table. So if you imagine, or no, we had Excel sheet, right? So if you just compare with that, this is like creating a new sheet. Like you just go to open Excel sheet and then go to new one, then create a new file, right? New file. So this is what it is. So this is just a Excel sheet sort of a thing. Connecting is nothing but it's like double clicking on that. So you open the file, and then create table is creating a new sheet. And then insert user is like making an entry in the Excel sheet. So there are so these are functions which are like which is written by this Copilot. But yeah, just to make it readable, we will go to each of these function and understand. And then once it is inserted here, we are just fetching all the users, which is printed here. And then you can also update that particular entry. So we are sending this. So, and also delete the user. Okay. So let us read through this, each of these functions, and try to understand. So let me close this. So if you just click Control or Command in your Mac, and then click left click, it will go to the functions. Okay. So this is your SQLite library, which is every database has got its own library. So there are different types of databases, just like requests library. So there is similar uh, libraries for data operating on databases. SQLite has its own library called SQLite 3. So this takes in database name, which is nothing but your file that we had sent here, example.db. You can also see that example.db, it must be created somewhere here. Is it deleted or yeah, here, example.db. You can see that, right? So if you click on that, it says that it's a binary file, you cannot open it. Let's go back here. So what does a cursor mean? Just like file descriptors. So we were studying about file operations, right? So we did with open, as, fd, and so on, right? So similarly, cursor is something, it is a handle to operate on the database. So you create a connection, connect to DB, and then you create a table. So using the cursors, connection is just you're connecting and you get a connection parameter. So using that connection, you create a cursor. So with Excel sheet, you can imagine that when you double click, the file gets open, right? So how, and now your mouse pointer is like your handle to like navigate through Excel sheet. So that is the connection. So that is what you get out of this. So with that connection, you can get the cursor, invoke the cursor. It is like clicking on one of the cells. So first cell of say your Excel sheet. So that is your cursor, and then you execute something. So this is, so all these databases have got SQL. This is SQL based databases, right? So there is a command to create table. So create table, if not exit, you can you can any table. Now you know that just like Excel sheet, a table name and its attributes. So that is what it is creating. You don't have to remember. You can just like glance it. Create table is the command, and if not exists, if that table does not exist, the create table called as users. And what goes into it is mainly two attributes. Three attributes: email, age, and name. And then there is ID. ID is nothing but like the first column where you have got numbers. So that this is what it does. By default, it does. So you can also like mention what sort of primary key you want. Okay. So we have created table here using the cursor. So connection, cursor, and then using that you have created a table. So once you have created a table, so we inserted a user. User using what? Using the connection. So you have a sheet, you have that particular thing. So using this connection, you're using this. So how it is used, insert connection. Again, you get the cursor. So any operation that you are done, so you sort of close that connection. So that is what this means. So committing is nothing but anything that you execute, right? So it is still in the RAM, and the RAM, as you know, it's still it has not gone to file system. So in order to execute and make sure that the file system is written, just like our file, right? We did fd.write, which is nothing but to write on this one, and then we fd.close. So when we actually write, uh, this is what is similar to that. So connection.commit means you are writing to the hard disk. So now you know that there is connection, there is cursor, there is some execution using that cursor, and then you have to save your file, just like Control S on your Excel sheet. This is what it does. So Control S is dot commit. Okay. And then you have got insert user. So this is like getting the cursor and then inserting a new value into your table in the new sheet. So what is the, so we have just parameterized that. That's all. So inserting Alice 30, and so inserting, and this comes as parameters. Now we know that what are parameters and how it gets used inside the function. So you just execute this particular query and commit it. So and it's like Control S. Okay, same thing. Okay. And then you can fetch all users, which is nothing but read. Is this read is nothing but, again, you get the cursor, execute. Sorry, where is read? This is insert. Okay, read is fetch all users. Cursor, and the query for reading everything is select star from users. So you got execute. All these operations can be done directly on the database. Okay, that is what database administrator do. He can open a terminal. I'm not sure if I have it, but it's not there. But you can actually get into SQLite, not SQLite, MySQL. It's not installed. Okay. But yeah, you can do all of these operations without Python, right? So that is what people have been doing so far. Even now, people do get into the terminal and run these queries on their database terminal. So and execute it. That's all. So now we have got these functions where you can insert, you can read and things like that. So how do you update a particular user, right? You need that particular user ID and what exactly you need to update. So these parameters, which are like initialized here in this, is called as default parameters. I'll tell you about this. So we didn't study this in during our functions, but yeah, so this is how it works. So when you use update user, right? Update user anywhere in your code. So just look at this part. This part does not have any sort of equal to something here. Okay, they are not initialized. So these are initialized, initiated, and these are called as default arguments. Default. So what is the advantage is that you can call update user with your connection ID and just user ID. Okay, some user ID which you have passed, and you can call it like this without passing these things. That is because once you call this, it goes and fetches this and assumes that these are the default arguments which are already initialized, and I'll just take it as is. Okay. So this is called as default arguments. So what happens when you call, say, update user, connection user, you want also name to be sent here. So you can simply call connection user and also the name. So same functions can be function can be used in different flavors. Like this has got 2 parameters, this has got 3 parameters, and you can also have like 4 parameters and so on. So by default, if you don't provide any value, it will use the default value here. If you provide a new value, so it won't take this. So that is what a default argument in a function means. Update also. So when you update, you need to know which row and say column that you need to update, right? So you need to know the sheet and then you go to that particular sheet. So how do you do that? Here is you, let us walk through from here, update user, and then obviously you need connection. And then one, what is one, we will see. So if you just hover on this, you can see the function signature, which is um, update user and what parameters it has got. So second one is user ID. So and name. So user ID is nothing but here. So and then you can pass anything that you want to update. So user one. So in the first this one I'm trying to update name. Okay. Let us see what it is. Um, update users set. So this is a query. We are actually in this part, we are actually forming the query. So finally, what the query that you want, if you want to look at the query, I'll just print the query here. Now print executing query. Okay, this is fine. Okay. Let me just execute this. You can see that it has generated a query using these parameters. Okay, like yeah. So because you can update multiple things, you can update the name, you can update the age, you can update the email. So for that, it either you can have code for each of these, or you can generate SQL query in one shot, and then you can do this. So that is what it is doing automatically. So you can, in fact, write the query individually here in each of these sections. But it is, we are just generating the query and appending the parameters, because the basic update users set, this part is common for everything. So that is why it has taken that as a variable. And then based on these other variables, it is generating the query. So that is about update. Update has got, instead of like select, it has got update users and you're setting certain things. So this is nothing but you're going to a particular cell and changing the value. So update is, that is what is update. So I want you guys to like take this program and anyways check it in the GitHub, and try to take this and we have a program to take in, where is that? That is loops. We have this program which takes in username, right? Username and age. So additionally, you take modify this program to take email ID as well. And once you get these three values, that is name, age, and email ID, use the program that we just wrote, which is dbops, and try to create a table called as subscribers.db, where you can insert, as you enter, take those values and invoke these functions and create a database. So that will be your exercise for today. So once you do that, you'll understand what all these things are. So you already know like Excel sheets or spreadsheets. You are just trying to realize that in code using like a database is similar to that, and you're just kind of mentally playing around with the same model. Sheet is nothing but a table. Each row and column is a cell. So here you can use cursor to go to that particular point, and there are some commands to operate on the database, delete, select, and so on. So you can just ask this Copilot to generate code for you, but get it done in the sense that you should be able to understand. Okay, now I take this. You're connecting two things, right? Your one is your loops.py, which is here. It does not have one thing, which is human ID, and it just prints currently. So instead of printing, get that individual entry and pass it on to DB. So it should be that is exercise. So you're connecting two things. So use Copilot. It's much simpler, but finally you should be able to get the database done. Say enter 10 names and 10 entries, and then you should be able to read them. So that is your exercise. Yeah, that is about SQLite 3. Similarly, you can have multiple databases as well. I'll just show you the snippets for others, which has like IP address and all these things. Okay. Okay. Give me a snippet for MySQL database. So this is another type of database. Okay. So this is like a full-fledged database where you need username and password as well. So you can see that this particular snippet here. So just like we used we were using so far SQLite, right? SQLite database. The library that we were using to operate on SQLite database was SQLite. Okay, we imported this and used this. So this is a library which operates on this, right? So this is called as what do you call it? It's connector or broker or something like that, which connects between your database and your Python script. So every database has got its own connectors like this, like okay. So MySQL has got import MySQL. This is the adapt. Okay, it is they're called as adapters. Adapter. Each of the databases has got adapters. The reason that it's called as adapters is because your MySQL database is itself it's a different software, right? All the databases are by themselves. When it is running as a service, it is a software by itself. So you are connecting this software and your Python script here. So these things, Python is not aware about how this works, right? So people have written libraries to access these services or these databases, how to access databases. So that is why they are called as adapters, to adapt to something. Okay. So yeah. MySQL connector, this is an adapter, and using that exactly similar to what we did. So we create a connection and then we take a cursor. You can see that SQL is similar to like what we did in SQLite 3. So slightly there will be changes in say Postgres and MySQL, but almost similar, like create a table, select, update, all these things are similar. So SQL stands for structured query language, right? So that is common for all the SQL databases. So it has got its own connector. And in SQLite 3, we just connected with connect to DB and just file name. Okay, this is our file name. So we didn't have any username and password. Now you can see that MySQL has got that that particular database has got hostname, username, and password. And in that particular machine, there could be why you should also specify database is that in that particular machine, say some xyz.com, here you could be running multiple processes and databases, right? So this could be like one database, two database, multiple databases. So you have got host name here and your username and password, and you must be able to connect to one particular database, right? So that is the reason you are passing that particular database name as well. So it's similar, but additionally, it has got username and password. You can try this, but but just understand for now, and then you can. In fact, you can install MySQL on your laptop and try this out, which is a good exercise. And even better exercise is host that in another system if you have some other system or friend system or somewhere, and you can try to connect using these connections. So that is like advanced thing that you can do to learn. Yeah, but for now, just make sure that you do this exercise. So that will help you to understand things about database. So yeah, you can see that it's almost similar code for this one, except this connection parameter. Everything else is almost same, right? Yeah, you can actually look at generate for Postgres. It's a different type of database, and you can see that the adapter will be different for this. You can see that adapter is called as PSYCOPG2, right? This is the adapter, and it is almost similar. Connected DB, host, database user, password, exactly similar. The structure slightly might change between MySQL and PostgreSQL, but it's almost similar. Okay, because you can read and understand what's happening. In fact, if you don't understand this, you know what to do, right? You can just say that, explain this, Copilot explain, as simple as that. So it explains very nicely. Okay. So that is how you need to learn, and that is how we like even experienced people are learning, because things are changing in a fast pace. Okay, so yeah, that is about database. What the types of different database types, and what are the like nuances of databases. There are like four operations. One is to read, which is read operations, and one is to create, one is to update, and one is to delete, which are like similar operations that we did on HTTPS REST APIs. So get, post, delete, and what is the other thing? Update, which is patch. So patch we did not do, but yeah, patch is one of this. So these database operations are mapped to these REST operations. So whenever you see patch, that means inside code somebody is writing update code somewhere. So not insert, update. Yeah, it gets hit. So if that's the design. Okay. So yeah, that's about databases, and we also looked at how it runs, and try out the exercise that I was telling. You'll understand it decently. Okay. Yeah, good. Yeah, thanks for joining. Tomorrow we will learn about creating our own service, which is using some libraries where we can run our own server, and we can just connect it. Okay. Okay. See you guys. Bye. Have a nice day.